A timeline of atomic and subatomic physics. Early beginnings. 600 BCE, Canada theorizes the existence of 4 kinds of atoms, which could combine to produce diatomic and triatomic molecules. 430 BCE, Democritus speculates about fundamental indivisible particles, calls them atoms. 200 BCE, Jainism calls atom Paramanwa, which can neither be created nor destroyed. It is eternal, i.e., it existed in the past, exists in the present and will continue to exist in the future. It is the permanent basis of the physical existence. The entire physical existence is composed of these ultimate atoms. The beginning of chemistry. 1766, Henry Cavendish discovers and studies hydrogen. 1778, Carl Scheele and Antoine Lavoisier discover that air is composed mostly of nitrogen and oxygen. 1781, Joseph Priestley creates water by igniting hydrogen and oxygen. 1800, William Nicholson and Anthony Carlisle use electrolysis to separate water into hydrogen and oxygen. 1803, John Dalton introduces atomic ideas into chemistry and states that matter is composed of atoms of different weights. 1805, Thomas Young conducts the double slit experiment with light. 1811, Amadeo Avogadro claims that equal volumes of gases should contain equal numbers of molecules. 1832, Michael Faraday states his laws of electrolysis. 1871, Dmitry Mendeleev systematically examines the periodic table and predicts the existence of gallium, scandium, and germanium. 1873, Johannes van der Waals introduces the idea of weak attractive forces between molecules. 1885, Johann Balmer finds a mathematical expression for observed hydrogen line wavelengths. 1887, Heinrich Hertz discovers the photoelectric effect. 1895, William Ramsay discovers terrestrial helium by spectroscopically analyzing gas produced by decaying uranium. 1896, Antoine Becquerel discovers the radioactivity of uranium. 1896, Peter Zeeman studies the splitting of sodium D lines when sodium is held in a flame between strong magnetic poles. 1897, Emil Wickett, Walter Kaufmann and J.J. Thomson discover the electron. 1898, William Ramsay and Morris Travers discover neon, and negatively charged beta particles. Timeline of classical mechanics. The age of quantum mechanics. 1887, Heinrich Rudolf Hertz discovers the photoelectric effect that will play a very important role in the development of the quantum theory, with Einstein's explanation of this effect in terms of quanta of light. 1896, Wilhelm Conrad Röntgen discovers the X-rays while studying electrons in plasma, scattering X-rays that were considered as waves of high energy electromagnetic radiation. Arthur Compton will be able to demonstrate in 1922 the particle aspect of electromagnetic radiation. 1900, Paul Villard discovers gamma rays while studying uranium decay. 1900, Johannes Rydberg refines the expression for observed hydrogen line wavelengths. 1900, Max Planck states his quantum hypothesis and blackbody radiation law. 1902, Philip Leonard observes that maximum photoelectron energies are independent of illuminating intensity but depend on frequency. 1902, Theodor Svedberg suggests that fluctuations in molecular bombardment cause the Brownian motion. 1905, Albert Einstein explains the photoelectric effect. 1906, Charles Bachelet discovers that each element has a characteristic X-ray and that the degree of penetration of these X-rays is related to the atomic weight of the element. 1909, Hans Geiger and Ernest Marsden discover large-angle deflections of alpha particles by thin metal foils. 1909, Ernest Rutherford and Thomas Royds demonstrate that alpha particles are doubly ionized helium atoms. 1911 Ernest Rutherford explains the Geiger-Marsden experiment by invoking a nuclear atom model and derives the Rutherford cross-section. 1911 Jean Perrin proves the existence of atoms and molecules. 1911 Stefan Prokopiou measures the magnetic dipole moment of the electron. 1912 Max von Laue suggests using crystal lattices to diffract X-rays. 1912 Walter Friedrich and Paul Knipping diffract X-rays in zinc blende. 1913 William Henry Bragg and William Lawrence Bragg work out the Bragg condition for strong X-ray reflection. 1913 Henry Moseley shows that nuclear charge is the real basis for numbering the elements. 1913 Niels Bohr presents his quantum model of the atom. 1913 Robert Millikan measures the fundamental unit of electric charge. 1913 Johannes Stark demonstrates that strong electric fields will split the Balmer spectral line series of hydrogen. 1914 James Franck and Gustav Hertz observe atomic excitation. 1914 Ernest Rutherford suggests that the positively charged atomic nucleus contains protons. 1915 Arnold Sommerfeld develops a modified Bohr atomic model with elliptic orbits to explain relativistic fine structure. 1916 Gilbert N. Lewis and Irving Langmuir formulate an electron shell model of chemical bonding. 1917 Albert Einstein introduces the idea of stimulated radiation emission. 1918 Ernest Rutherford notices that, when alpha particles were shot into nitrogen gas, his scintillation detectors showed the signatures of hydrogen nuclei. 1921 Alfred Landé introduces the Landé G-factor. 1922 Arthur Compton studies X-ray photon scattering by electrons, demonstrating the particle aspect of electromagnetic radiation. 1922 Otto Stern and Walther Gerlach show spin quantization. 1923 Lise Meitner discovers what is now referred to as the Auger process. 1924 Louis de Broglie suggests that electrons may have wave-like properties in addition to their particle properties. The wave-particle duality has been later extended to all fermions and bosons. 1924 John Leonard Jones proposes a semi-empirical interatomic force law. 1924 Sacchi-Ender boson. Albert Einstein introduced Bose-Einstein statistics. 1925 Wolfgang Pauli states the quantum exclusion principle for electrons. 1925 George Uhlenbeck and Samuel Goldsmith postulate electron spin. 1925 Pierre Auger discovers the Auger process. 1925 Werner Heisenberg, Max Born, and Pascual Jordan formulate quantum matrix mechanics. 1926 Erwin Schrödinger states his non-relativistic quantum wave equation and formulates quantum wave mechanics. 1926 Erwin Schrödinger proves that the wave and matrix formulations of quantum theory are mathematically equivalent. 1926 Oscar Klein and Walter Gordon state their relativistic quantum wave equation, now the Klein-Gordon equation. 1926 Enrico Fermi discovers the spin statistics connection for particles that are now called fermions, such as the electron. 1926 Paul Dirac introduces Fermi-Dirac statistics. 1926 Gilbert N. Lewis introduces the term photon, thought by him to be the carrier of radiant energy. 1927 Clinton Davison, Lester Germer, and George Paget Thomson confirm the wave-like nature of electrons. 1927 Werner Heisenberg states the quantum uncertainty principle. 1927 Max Born interprets the probabilistic nature of wave functions. 1927 Walter Heitler and Fritz London introduce the concepts of valence bond theory and apply it to the hydrogen molecule. 1927 Thomas and Fermi developed the Thomas-Fermi model. 1927 Max Born and Robert Oppenheimer introduced the Born-Oppenheimer approximation. 1928 Chandrasekhara Raman studies optical photon scattering by electrons. 1928 Paul Dirac states his relativistic electron quantum wave equation. 1928 Charles G. Darwin and Walter Gordon solved the Dirac equation for a Coulomb potential. 1928 Friedrich Hund and Robert S. Mulliken introduced the concept of molecular orbital. 1929 Oscar Klein discovers the Klein paradox. 1929 Oscar Klein and Yoshio Nishina derived the Klein-Nishina cross-section for high-energy photon scattering by electrons. 1929 Neville Mott derives the Mott cross-section for the Coulomb scattering of relativistic electrons. 1930 Paul Dirac introduces electron-hole theory. 1930 Erwin Schrödinger predicts the Zitterbewegung motion. 1930 Fritz London explains van der Waals forces as due to the interacting fluctuating dipole moments between molecules. 1931 John Lennard-Jones proposes the Lennard-Jones interatomic potential. 1931 Irene Joliot-Curie and Frédéric Joliot observe but misinterpret neutron scattering in paraffin. 1931 Wolfgang Pauli puts forth the neutrino hypothesis to explain the apparent violation of energy conservation in beta decay. 1931 Linus Pauling discovers resonance bonding and uses it to explain the high stability of symmetric planar molecules. 1931 Paul Dirac shows that charge quantization can be explained if magnetic monopoles exist. 1931 Harold Urey discovers deuterium using evaporation concentration techniques and spectroscopy. 1932 John Cockcroft and Ernest Walton split lithium and boron nuclei using proton bombardment. 1932 James Chadwick discovers the neutron. 1932 Werner Heisenberg presents the proton-neutron model of the nucleus and uses it to explain isotopes. 1932 Carl D. Anderson discovers the positron. 1933 Ernst Stueckelberg, Lev Landau, and Clarence Zener discover the Landau-Zener transition. 1933 Max Delbruck suggests that quantum effects will cause photons to be scattered by an external electric field. 1934 Irene Joliot-Curie and Frédéric Joliot bombard aluminium atoms with alpha particles to create artificially radioactive phosphorus-30. 1934 Leo Szilard realizes that nuclear chain reactions may be possible. 1934 Enrico Fermi publishes a very successful model of beta decay in which neutrinos were produced. 1934 Lev Landau tells Edward Teller that nonlinear molecules may have vibrational modes which remove the degeneracy of an orbitally degenerate state. 1934 Enrico Fermi suggests bombarding uranium atoms with neutrons to make a 93-proton element. 1934 Pavel Cherenkov reports that light is emitted by relativistic particles traveling in a non-scintillating liquid. 1935 Hideki Yukawa presents a theory of the nuclear force and predicts the scalar meson. 1935 Albert Einstein, Boris Podolsky, and Nathan Rosen put forth the Epr paradox. 1935 Henry Eyring develops the transition state theory. 1935 Niels Bohr presents his analysis of the Epr paradox. 1936 Alexandru Proca formulates the relativistic quantum field equations for a massive vector meson of spin 1 as a basis for nuclear forces. 1936 Eugene Wiener develops the theory of neutron absorption by atomic nuclei. 1936 Hermann Arthur Jahn and Edward Teller present their systematic study of the symmetry types for which the Jahn-Teller effect is expected. 1937 Carl Anderson proves experimentally the existence of the pion predicted by Yukawa's theory. 1937 Hans Hellmann finds the Hellmann-Feynman theorem. 1937 Seth Neddermeyer, Carl Anderson, J.C. Street, and E.C. Stevenson discover muons using cloud chamber measurements of cosmic rays. 1939 Richard Feynman finds the Hellmann-Feynman theorem. 1939 Otto Hahn and Fritz Strassmann bombard uranium salts with thermal neutrons and discover barium among the reaction products. 1939 Lise Meitner and Otto Robert Frisch determine that nuclear fission is taking place in the Hahn-Strassmann experiments. 1942 Enrico Fermi makes the first controlled nuclear chain reaction. 1942 Ernst Stueckelberg introduces the propagator to positron theory and interprets positrons as negative energy electrons moving backwards through spacetime. 1943 Shinichiro Tomonaga publishes his paper on the basic physical principles of quantum electrodynamics. 1947 Willis Lamb and Robert Rutherford measure the Lamb-Rutherford shift. 1947 Cecil Powell, C. Acute SAR lattes, and Giuseppe Occhialini discover the pi meson by studying cosmic ray tracks. 1947 Richard Feynman presents his propagator approach to quantum electrodynamics. 1948 Hendrik Casimir predicts a rudimentary attractive Casimir force on a parallel plate capacitor. 1951 Martin Deutsch discovers positronium. 1952 David Bohm proposes his interpretation of quantum mechanics. 1953 Robert Wilson observes Delbruck scattering of 1.33 MeV gamma rays by the electric fields of Lie nuclei. 1953 Charles H. Towns, collaborating with J. P. Gordon and H. J. Zeiger, builds the first ammonia maser. 1954 Chen-Ning Yang and Robert Mills investigate a theory of hadronic isospin by demanding local gauge invariance under isotopic spin space rotations. The first non-abelian gauge theory. 1955 Owen Chamberlain, Emilio Segre, Clyde Wiegand, and Thomas Ypsilantis discover the antiproton. 1956 Frederick Rain and Clyde Cowan detect antineutrino. 1956 Chen-Ning Yang and Sung Lee propose parity violation by the weak nuclear force. 1956 Chen Qiang-Wu discovers parity violation by the weak force in decaying cobalt. 1957 Gerhard Luders proves the CPT theorem. 1957 Richard Feynman, Murray Gell-Mann, Robert Marshak, and E.C.G. Sudarshan propose a axial vector Lagrangian for weak interactions. 1958 Marcus Spamai experimentally confirms the Casimir effect. 1959 Yukir Aharonov and David Bohm predict the Aharonov-Bohm effect. 1960 R.G. Chambers experimentally confirms the Aharonov-Bohm effect. 1961 Murray Gell-Mann and Yuval Neeman discover the eightfold wave patterns, the SU group. 1961 Jeffrey Goldstone considers the breaking of global phase symmetry. 1962 Leon Liederman shows that the electron neutrino is distinct from the muon neutrino. 1963 Eugene Weiner discovers the fundamental roles played by quantum symmetries in atoms and molecules, the formation and successors of the Standard Model. 1964 Murray Gell-Mann and George Zweig propose the quark-aces model. 1964 Peter Higgs considers the breaking of local phase symmetry. 1964 John Stuart Bell shows that all local hidden variable theories must satisfy Bell's inequality. 1964 Val Fitch and James Cronin observe CP violation by the weak force in the decay of K-mesons. 1967 Steven Weinberg puts forth his electroweak model of leptons. 1969 John Clauser, Michael Horn, Abner Shimony and Richard Holt propose a polarization correlation test of Bell's inequality. 1970 Sheldon Glashow, John Iliopoulos, and Luciano Maiani propose the charm quark. 1971 Gerard T. Hooft shows that the Glashow-Salam-Weinberg electroweak model can be renormalized. 1972 Stuart Friedman and John Clauser perform the first polarization correlation test of Bell's inequality. 1973 David Politzer and Frank Anthony Wilczek propose the asymptotic freedom of quarks. 1974 Burton Richter and Samuel Ting discover the J-psi particle implying the existence of the charm quark. 1974 Robert J. Buenker and Sigrid D. Payuimhoff introduced the multi-reference configuration interaction method. 1975 Martin Pearl discovers the tau lepton. 1977 Steve Herb finds the upsilon resonance implying the existence of the beauty-bottom quark. 1982 Alan Aspect, Dalibard, and G. Roger perform a polarization correlation test of Bell's inequality that rules out conspiratorial polarizer communication. 1983 Carlo Rubbia, Simon van der Meer, and the CERN UA1 collaboration find the W and Z intermediate vector bosons. 1989 The Z intermediate vector boson resonance width indicates 3 quark-lepton generations. 1994 The CERN Lear crystal barrel experiment justifies the existence of glue balls. 1995 After 18 years searching at Fermilab was discovered the top quark. It had very big mass. 1998 Super Kamiokanda observes evidence for neutrino oscillations, implying that at least one neutrino has mass. 1999 Ahmed Zewail wins the Nobel Prize in Chemistry for his work on femtochemistry for atoms and molecules. 2001 The Sudbury Neutrino Observatory confirms the existence of neutrino oscillations. 2005 At the RHIC accelerator of Brookhaven National Laboratory they have created a quark-gluon liquid of very low viscosity, perhaps the quark-gluon plasma. 2008 The Large Hadron Collider at CERN is scheduled to begin operation in this year. Its primary goal is to search for the Higgs boson, which has not yet been found. 2012 CERN announces the discovery of a new particle with properties consistent with the Higgs boson of the Standard Model after experiments at the Large Hadron Collider. Quantum field theories beyond the Standard Model. 2000 Steven Weinberg, Supersymmetry and Quantum Gravity. 2003 Leonid Vaineman, Quantum Groups, Hopf Algebras and Quantum Field Applications. Non-Commutative Quantum Field Theory. M.R. Douglas and N.A. Nekrasov. Non-Commutative Field Theory, Rev. Mod. Phys. 73. 977-1029. Szabo, J. Quantum Field Theory on Non-Commutative Spaces. Physics Reports 378. 207-99. An expository article on non-commutative quantum field theories. Non-commutative quantum field theory. See statistics on arXiv.org. Seiberg and D. Witten, String Theory and Non-Commutative Geometry, Journal of High Energy Physics. Sergio Doplica, Klaus Fredenhagen and John Roberts. Sergio Doplica, Klaus Fredenhagen, John E. Roberts. The Quantum Structure of Space-Time at the Planck Scale and Quantum Fields. Commune. Math. Phys. 172. 187-220. Alan Connors Non-Commutative Geometry. Academic Press. ISBN 0-12-185860-X. Non-Commutative Geometry in Reality. Math. Phys. 36. 6194. Gravity coupled with matter and the foundation of non-commutative geometry. Cum. Math. Phys. 155. 109. Non-Commutative Geometry in Physics. And M. Marcoli. Non-Commutative Geometry. Quantum Fields and Motives. American Mathematical Society. Chamsedina, A. Conis. The Spectral Action Principle. Cum. Math. Phys. 182. 155. Chamsedina, A. Conis. Marcoli. Gravity and the Standard Model with Neutrino Mixing. ADV. Thea. Math. Phys. 11. 991. Jurate, Jan H., Thomas Krajewski, Thomas Schucker, and Christoph A. Steffin, on the Non-Commutative Standard Model. Actiphys. Pollen. B. 38. 3181-3202. Schucker, Thomas. Forces from Conses Geometry. Lecture Notes in Physics 659. Springer. Non-Commutative Standard Model. Non-Commutative Geometry.